Let's move on to item number 41. A bag is tied to the top of a 5-meter ladder resting against a vertical wall. Suppose the ladder begins sliding down the wall in such a way that the foot of the ladder is moving away from the wall. How fast is the bag descending at the instant the foot of the ladder is 4 meters from the wall and the foot is moving away at the rate of 2 meters per second? Is it 8/3, -8/3, -5/4, or 5/4? Let's solve this problem now. And I hope you got this correctly. Now, so from here, this is the illustration. This is the wall. This is the bag here, or the object. That's the bag, yes. And as what you could see, the ladder is 5 meters long. It's here. And let's call this X, and let's call this, say, Y. And remember, the bag is descending. So I am expecting that the dy over dt, or the rate of the movement of the bag, will be negative because it goes down, and besides, the distance here is becoming smaller, and I'm expecting that it will be larger for it will be positive for the dx over dt. By the Pythagorean theorem, we know that x squared plus y squared is 5 squared. And if we will get now, we know that 5 squared is 25, by the way. So we have here x squared plus y squared equals 25. And what will happen next is we will differentiate both sides of the equation with respect to time to get our rates. Now, so differentiating each with respect to time, you have 2x times dx over dt. For the y squared will be 2y, the power rule, and the derivative of y, it's with respect to t, is dy over dt equals the derivative of 25 with respect to time, which is 0. And from here, we know certain values, that your x is 2 earlier, right? Your x is 2. And however, this is so far what is known. We know that your x is 2 earlier here, but we don't know the length of your y. Hence, we will solve for that using the Pythagorean theorem. Because earlier, this was, your x is 4, that was given rather, sorry, x is 4. So by the Pythagorean theorem, so 4 squared plus y squared equals 5 squared. And you could see that y squared is equal to 25 minus 16, or 9, and y is plus minus 3, because you will take the plus minus the square root of both sides. However, y is a side of this triangle. And when we speak about sides, it has to be positive. That's why we are discarding the negative part, and we will adapt the positive sign for y. Remember as well that rates could be negative, but side lengths should be positive. So we know now that y is 3. So we will replace this y now with 3. And so you have 2 times 4 times 2 plus 2 times 3 times dy over dt equals 0. This becomes 16 plus 6 times dy over dt. Then you will subtract both sides by 16 and divide both sides by 6. Then you have dy over dt, which is -8/3. But the problem is asking how far is it descending? So we should answer letter A. It's descending at 8/3 meters per second. Because if you answer negative, it's descending at -8/3. That's double negative. It's not that. That should be, if that's the case, that would be a redundancy. That's why we had to get the letter A. 42. Evaluate the integration of x minus 3 times x plus 4 dx. So which of these is the correct integration? Now, so from here, it's better if you multiply them first. And if you multiply these two binomials, you will get the product, which is x squared plus x minus 12. You could verify that by multiplication. And for the power rule for integrals, what we need to do is we add the exponent by 1. And whatever the exponent is, that will also be your denominator. So for here, 2 plus 1 will be 3. That's why x raised to 3 all over 3. Plus, add the exponent by 1. That's 1 plus 1, 2. But whatever the exponent, it should also be in the denominator. That's why x squared plus over 2. And the integration of negative 12 is negative 12x. But let us not forget plus c, our arbitrary constant. And in this case, the correct answer is letter C. Moving on to number 43. Evaluate the integration of 3x squared from 1 dx from 1 to 4. So using again the same technique earlier, but this time we will be using one of the fundamental theorems of calculus. So by doing such, you will add 1 to the exponent, so it will become 3x cubed over 3, and it will be x cubed only. And if you could notice, we have upper and lower and upper limits, so there's no need for plus c. The plus c is only for indefinite integrals. And after which, we now have to evaluate this. We will substitute the 4 to x cubed. We will also substitute the 1 to the x here. And we will subtract the results based on the fundamental theorem of calculus. And we have 4 cubed minus 1 cubed, which is 64 minus 1, or 63, letter D. Next number, 44. Find the area in square units of the region bounded by y equals 2 minus x squared and y equals negative x. Is it 4, 4.5, 5, or 5.5? So in this case, what many do here, it's very beneficial if you know how to graph them in the Cartesian plane. And for now, I will give you the graph. It looks like this. And if you could see, we are looking at the area bounded by the area of the closed region bounded by the blue line and the red portion of your and the parabola. And remember, we have your upper and your lower function. And to get the area, we actually we subtract f of x and g of x. F of x here usually denotes the upper function. Like if you draw here a rectangle strip, the part that of the graph the rectangle touches will be the upper function, and the one at the bottom will be the lower function. Our upper function here is this one, 2 minus x squared, and the lower function will be negative x. And we could see that to get the points of intersection, the x coordinates of the points of intersection, we could actually use this. We could equate them. And by equating the x, you could arrive to this quadratic trinomial, x squared minus x minus 2 equals 0. It's factorable as x plus 1 times x minus 2 equals 0. And the value of x is negative 1 and 2. And that's why you could see here that two of them intersect when x is negative 1. And they also intersected at this part when the value of x is 2. And negative 1 and 2 will be the lower and the upper limits of your integration. So with that, this means that the curves intersect at x equals negative 1 or x equals 2, and thus our interval will be at the closed interval negative 1, 2, where a here is is the lower boundary here. This one rather will be -1, and your b will be 2. By substitution now, you have the integration of 2 minus x squared minus -x dx as it goes from -1 to 2. Simplifying that gives you -x squared plus x plus 2. And to integrate them now using the power rule, you will add 1 to the exponent. So here, 2 plus 1, 3. That's why you have here 3 denominator. It's -x cubed over 3 here. For the integration of x, x plus 1 plus 1, 2 all over 2. That's why plus x squared all over 2 plus 2x. And we are talking about definite integrals. That is why we have to evaluate. There's no more plus c, and we will evaluate them using our theorems in calculus. So with that, we will substitute 2 to the function here. We will also substitute -1 to x here. Then we will subtract the results. So upon doing that, we arrive to this expression, and it's time now to simplify them. So we have here the first one, the -2 cubed over 3. It's okay, this one. I think it's just copied. It becomes -8/3 plus this one becomes 2. The 2 times 2 is 4. Negative of -1 cubed over 3, it's positive 1/3. The -1 squared will be 1 over 2, and this is -2, and you have to subtract them. And doing such using your calculators, that's 4.5 square units. Therefore, the correct answer here is letter B. Okay, 45. Find the area of the region bounded by y equals x squared plus 2, y equals -1, and x equals -1, and x equals 2. So, is it 8, 8.9, 12, or 15? So in this case, it's good if we graph them first. This is how the graph looks like. This is the vertical line, x equals -1. This is the vertical line, x equals 2. This is the horizontal line, y equals -1. And this is the parabola, f of x equals x squared plus 2. You could see that in here, we could see from here that using again this theorem, we know that the interval is from -1 and 2 because that's the limits for our x. And your upper function, if you draw again another rectangle here, a vertical rectangle, the upper function will be your f of x equals x squared plus 2, and the lower function will be f of x or y equals -1. So we will subtract upper minus lower, and the lower limit will be -1, and the upper limit will be 2. So from here, x squared plus 2 minus -1, when simplified, will become x squared plus 3, as evaluated from the lower limit -1 to 2. And integrating again, you get x cubed over 3 plus 3x. You will substitute and of course, you will evaluate this at x equals 2, at x equals -1, and subtract the results. So with that, we have 2 cubed over 3 plus 3 times 2 minus -1 cubed over 3 plus 3 times -1. And using your calculators, you could actually see that the correct answer here is 36/3 or 12 square units. And that is letter C. I hope you got this correctly. Let's move on to item number 46. If R and S are the roots of x squared plus 4x plus 1 and equals 0, what is R plus 1 times S plus 1? Is it -2, -1, 1, or 2? Remember that to get the sum and product of the roots, we will use what we call Vieta's formulas. That is, the sum of the roots. If you could still remember, if you have a quadratic equation in standard form, ax squared plus bx plus c equals 0, then Vieta's formula for the sum of the roots is negative b over a. So in this case, negative 4 over 1, which is negative 4. For the product of the roots, I hope you could still recall the c over a. The c here is 1 and the a here is 1. So 1 over 1 will give you 1, which is your product of your roots. Now, what's also nice here is that you don't need to look for the exact roots. Even though you are looking for r plus 1 times s plus 1, you could actually multiply them using the FOIL method. R times s will be rs, r times 1 will be plus r, 1 times s will be plus s, and 1 times 1 will be plus 1. And from here, you could see that rs is negative 4, and that, rs is 1 rather, and that r plus s here is negative 4. And by substitution, this becomes 1 plus negative 4 plus 1, and that is negative 2. Hence, letter A is the correct answer here. That's the beauty of algebra. You don't need to look for the exact roots, but use the properties that are known to find the answer. 47. If x squared minus x plus 1 equals 0, find the value of x squared plus 1 over x squared. Is it negative 2, negative 1, 1 or 2? Again, in this case, the usual tendency of many is to solve really for the value of x, then substitute. But that is not necessary actually. Why is that so? Because from here, from this equation, what you need to do is add both sides by x, and you will have x squared plus 1 equals x. Then, by the way, in the first one, our product of the roots is 1 over 1, which is 1. So therefore, since the product of the roots is not 0, therefore, it is a good sign that the value of x is not 0, that no root is 0. That's why we can divide both sides by x, because x here is not 0 for sure. And if you divide each term by x, you will arrive to x plus 1 over x equals 1. And what's beautiful here is that we can now square both sides of x plus 1 over x equals 1. If you square this, x squared, then plus twice the product of the first and the second term. That's why you have here 2 times x times 1 over x, plus the square of 1 over x, which is 1 over x squared. And of course, the square of 1 is still 1. You could see that x times 1 over x is just 1, because a product of a number and its reciprocal is 1, provided that no number is 0 in this case. So this becomes x squared plus 2 plus 1 over x squared equals 1. Subtracting both sides by 2 to get our desired form, we have x squared plus 1 over x squared equals negative 1. And that is letter B. And you might ask, sir, x squared, you are adding 2 squares. How come the answer is negative? It's possible to be negative, especially if your roots are probably imaginary, for example. So it's possible to have a negative sum of squares. Okay? 48. What is the area in square units of an equilateral triangle with side 4 of 4? Is it 3 square root of 3, 4 square root of 3, 12 square root of 3, or 16 square root of 3? There are many ways of doing this problem, but for now, I'll just give you the shortcut. That is, the formula for the area of any equilateral triangle with side s is s squared square root of 3 all over 4, where s is the measure of a side. So here the side is 4. So we have area equals 4 squared times square root of 3 all over 4. 4 squared here is 16. 16 over 4 is 4. And you have for square root of 3 square units as your area. And that is letter B. I hope you got it. Let's move on to 49. If R minus S equals 4 and RS equals 3, what is the positive value of R plus S? Is it -5, -1, 5, or 7? Of course, since we are talking about positive value of R plus S, automatically A and B does not qualify here. But is it 5 or 7? Or is it really there? Let's see. From here, if you squared both sides of R minus S equals 4, you will get R squared minus 2RS plus S squared equals 16. And the simple technique here would be adding both sides by 4RS. That's the technique. This will do the trick here. And you might ask, how come do I need to do that? So that when you get the square root of R plus S, so that you could get the square root, which is R plus S later on. Now, I added 4RS both sides. The negative 2RS and the plus 4RS becomes plus 2RS. That's why the left side becomes R squared plus 2RS plus S squared. But the RS here, based on the given, has a value of 3. That's why I have here 4 times 3. 4 times 3 is 12, so the right side becomes 28. And we could express R squared plus 2RS plus S squared as a square of R plus S. That's the reason why we added 4RS earlier, because we could get a trinomial that is a perfect square trinomial and whose middle term is positive. So if this is the case now, we get the positive square root of both sides. This is R plus S quantity squared. That's why I got the square root of both sides. R plus S equals plus minus square root of 28. That's actually plus minus 2 square root of 7. But since we are after only of the positive value, that's the reason I omitted the negative value. And if you could see, neither one of the choices. Therefore, letter E is the correct answer here. And lastly, for this part, points N, M, and L are on the sides of right angle FGH such that GNML is a rectangle. If FL is 15 and NH is 5, find the area of rectangle GNML. Is it 25, 35, 70, or 75? You could actually see that they are similar. How come? This is a rectangle, therefore this is parallel to this one, and ML is parallel to HG as well. And since they are parallel, if this is alpha, this should also be alpha, because corresponding angles of similar triangles are equal. This is a alpha, alpha. This is beta. I mean, in this case, if this is alpha, this is also alpha because they are corresponding angles, sorry. This is also beta. This is also beta because they're corresponding. And you could see that they are in fact similar by AA similarity. That's why triangle FLM is similar to triangle MNH by AA similarity. In fact, you could also do AAA, but AA is also good. Now, because they're similar, then the ratio of their corresponding sides are also similar, is also similar. That is 15 over y for this triangle is equal to x over 5 in this smaller triangle here. With such, multiplying both sides by 5y, you arrive to xy equals 5 times 15 or 75 square units. And remember, the side length of the rectangle, the dimensions are x and y. So the area of this is xy. And by doing such, we were able to arrive to xy, which is 75 square units, even without knowing the actual dimensions of your two similar triangles. With that, the correct answer here is letter D. And I wish you joy and happiness in everything that you do. I hope you are having a great day, and God bless for your licensure examination for teachers. With that, TYVM, thank you very much and a great day to one and all. God bless everyone.